Statistical and critical thinking. In this section, we're going to talk about things we need when we try to use statistic, and how should we approach, what are the information we need, that type of thing. So first of all, whenever we try to work in statistics, we need data. So data means collection of observation such as measurement, genders, or survey response. Data could be anything. For example, you would like to find out average household income for a city, then you can collect the data for the income, household income. That's one example. Statistics, it's a science of planning studies and experiments, obtaining data and organizing, summarizing, presenting, analyzing, and interpreting those data, and then drawing conclusion based on them. So everything, collecting the data, analyzing them, from preparation phase to conclusion phase, that's everything is called statistics. It's a science of planning. Population means whenever we try to collect the data for that, for any reason, population is the entire thing. So the complete collection of all data that are being considered. Typically, a population is the complete collection of data that we would like to make inference about. For example, let's say we would like to find out, average household income in the United States of America. Then population for USA is whole population, who people, human who live in the country. So population means everything. And there are two ways we can go. Census means entire population, every member of the population. For example, that example I was talking, find out the average household income in for United States of America, USA. Then census is the collection of all the members from the population, entire country. Sample means it's a sub collection. So you collect the sample from different states. There are different ways to make a sample, and by using one of the way, we collect the sample. Okay, one example: watch what you post online. In a survey of 410 human resource professionals, 148 of them said that job candidates were disqualified because of information found on social media posting. This is the real information based on data from the Society for Human Resource Management. In this example, as you can see here, the population is all human resource professional. The sample we are using here is 410 human resource professional who were surveyed. And here this objective is to use the sample as a basis for drawing a conclusion about the population of all human resource professional. Remember, to work with a huge population, it could be very time consuming and very expensive. So that's why we always choose the sample. So there are three different phase when we try to use the statistics, statistical and critical thinking. There are three different phases. One is preparation phase, another one is analyzing phase, and finally the conclusion phase. In preparation phase, we need to collect the data. So first of all, what do the data represent? What is the goal of this study? We need to find out that. And then if we are collecting the data, then we have to make sure that the source of the data is valid. Are the data from a source with a special interest, so that there is a pressure to obtain a result that are favorable to the source. So we have to make sure that the source of data is authentic. Okay. Let's say, for example, one of the company, let's say medicine company, they claim that their medicine is 100% effective, and based on their experiment they have done in their lab. So they are claiming something based on their own work, so that could be something suspicious. So whenever someone makes some claim, for example, think about advertisement in TV, And if there are any claims they are making, then you have to make sure that based on what, who is doing that experiment, who is doing that data sampling, data collecting, and survey thing. So that's the source of data is very important. And then also sampling method, how they are collecting the sample, where the data collected in a way that is unbiased. Sometime you know uh, we could collect the data in a way that favors our favor our interest. So the data collection or sampling method should be unbiased. And yeah, that's very important thing. So that comes in preparation phase. After passing through the preparation phase, after collecting the data and making sure that it's unbiased data, and the data is coming from very reputable source, we could do analysis of data. And in the data analysis, we can use uh, different ways. We could plot the graph and look at the graph and find out the information or present the information, or we could find some other information. For example, uh, the mean, average, standard deviation, which we're going to cover in future in the course. That type of thing help us to analyze the data. So when analyzing the data, we have to also make sure that are there any outliers. For example, let's say you would like to find out average household income in a particular, let's say, neighborhood. And let's say, for example, there are 5 family in that neighborhood. And in those 5 family, one of the family makes, let's say, 1 million, and rest of the family they make less than 50K. Then this 1 million is outlier. And because of this outlier, the average income in that neighborhood could be very high. But we have to make sure that this outlier, we should make sure that we are taking care of this outlier. And we in the analyzing phase, we also have to make sure that how are the data distributed. Are there any missing data? So whilst collecting the data, if anybody refused to answer the question, or subject is refused to respond, so and then we while analyzing the data, we could use different technology, for example TI-8384 calculator, StatCrunch, or something else. And finally, going through this to a step, finally the final thing is conclusion. After analysis, what we conclude, and if we conclude something, do the results have statistical significance? And we're going to talk about that. What does that mean? And we're going to use that thing in our future discussion. Let's say one example. This is the preparation phase. Okay, let's say this is the table we're using. It's a shoe size, print size in centimeter, and height of the male in centimeter. So this is the data, and the context is the table includes shoe print length. So you can see that the first row is shoe size in centimeter, and second row is height of the male height of 8 males. And the context is forensic scientists measure shoe print lengths at burglary scene and other crime scene in order to estimate the height of the criminals. So this is coming from forensic scientists. They measure the shoe size and height. And the format of the table suggests that following goals. This is the goal. Determine whether there is a relationship between shoe print lengths and then height of the males. This goal suggests a reasonable hypothesis. Males with a larger shoe print length tend to be taller. We are using data for males only because 84% of burglaries are committed by males. This is just a preparation phase. But while in preparation phase, we also have to make sure that is this source of data reliable, and this data is from dataset 9, which is foot and height data, which I have mentioned here in the next page. This is the source of the data, and this source looks reliable. And what sampling method they are using here? The individuals were randomly selected, so the sampling method appears to be sound. So this comes in the preparation phase. We have to make sure that source is valid and sampling method is random. And then after that, as you can see here, if you go back to this page, sampling method. What sampling method they are using? And there is one sampling method called voluntary response sample. This is not good. Voluntary response sample or self-selected sample is one in which respondents themselves decide whether to be included. The following types of polls are common examples. So internet polls or mail-in polls or telephone calls where they are under voluntary response sample. And because it's voluntary, the data is not that reliable. So let's say one example here. The ABC television show Nightline asks viewer to call with their opinion about whether the United Nations headquarters should remain in the United States. Viewer then decided themselves whether to call with their opinions, and 67% of 186,000 respondents said that the United Nations should be moved out of the United States. So, so in a television show, viewers made a call, and 67% of them, out of 186,000, said that United Nations should be moved out of the United States. In a separate and independent survey, so this is the separate survey, okay, this is the separate one, and the difference between these two surveys, let's go to the separate one, the second one first. In a separate and independent survey, 500 respondents were randomly selected. This is the clue, this is the very, very important factor, and surveyed, and 38% of this group wanted the United Nations to move out of the United States. So look at here, two different type of survey method and two different results. This survey method is not reliable because it's a voluntary response sample, and this is reliable because it's a randomly selected. The two polls produce dramatically different results. Even though Nightline poll involved 186,000 volunteers responded, the much smaller poll of 500 randomly selected responded is more likely to provide better result. So always keep in mind, voluntary response sample, it does not provide, might not provide the right or correct result. And after that, so preparation phase, and now we are in the analyzing phase. So while analyzing, we have to use the graphs or some statistical methods, for example, average, or maybe standard deviation. So and that could help for the analyzing part. And finally, conclusion. So there are there is only one thing you have to keep in mind while making the conclusion, is the data gives you the statistical significance, meaning statistical significance is achieved in a study if the likelihood of an event occurring by chance is 5% or less. So for example, let's say getting 98 girls in 100 random birth is called statistically significant. So out of 100, 98 of them are girls. So this data is statistically significant because it's not random. So it's it's only 2%. So which means less than 5%. So this data is statistical significance. This finding is statistically significant. So we can use this finding. In another example, getting 52 girls out of 100, it could be random because as you can see here, it's a 48%, 52% chance, which is it could be happen randomly. So here this data is the conclusion is statistically significant, but this is not. And sometimes we also have to keep in mind about practical significance. For example, I can give you one example here. In a trial of weight loss programs, 21 subjects on the Atkins program lost an average of 2.1 kg, which is 4.6 pound. After 1 year, based on the data given here, the sources given here. So look at here. In weight loss program, 21 subjects on the Atkins program lost 2.1 kg. after 1 year. So now, however, so this is the first one. The result shows that this loss is statistically significant and is not likely to occur by chance. However, so this is statistical significance. That's what we have given. But even though this is statistical significance, most of the many dieters believe that after following this diet for a year, a loss of only 2.1 kg or 4.6 pound is not worth time and cost and effort. That's why it's not practically significant. Sometimes your data could be statistical significance, but practically we don't want to use that. So that's not practically significance. Okay. While analyzing the data, we also have to think about potential pitfalls. For example, misleading conclusion, sample data reported instead of measure, loaded question, order of question. So when we analyze the data, we have to make sure that how the survey was handled. For example, when forming a conclusion based on a statistical analysis, we should make statements that are clear even to those who have no understanding of statistics and its terminology. So while asking the question, we have to make sure that whoever is answering the question is understanding that question very carefully. Sample data reported instead of measure. When collecting data from people, it is better to take measurement yourself instead of asking subject to report result. This is a voluntary sample. So voluntary sample does not give actual correct information. Loaded question. If survey results are not worded carefully, sometimes the way we ask the question could give the answer differently. The result of a study can be misleading, and sometimes the order of operation could also affect the answering. So we have to think about this. These are the things while analyzing the data. Sometimes you don't get the response. Sometimes the response rate is very, very low, and sometimes the percentage. Some studies cite a misleading percentage. Note that 100% of some quantity is all of it. But if there are references made to percentages that exceed 100%, such references are often not justified. So we have to keep in mind this thing while analyzing the data. Okay. Now I'm going to go over some examples for this section here. Let's say one example. In an AOL survey of internet user, this question was posted online. Have you ever been hit by a computer virus? Among the 170,063 responses, 63% answer yes. What term is used to describe this type of survey in which the people surveyed consist of those who choose to respond? What is wrong with this type of sampling method? So first question is, what term is used to describe this type of survey? The responded are a self-selected sample. So this is actually right. This is self-selected sample. The responded are a census. No, they are not everything. So it's not the right one. The responded are a population. No. The responded are a voluntary response sample. Yes, they are volunteers. Good job. If you go to the next question, what is the wrong with this type of sampling method? The survey question is loaded. There is, have you ever been hit by a computer virus? This is not loaded. Loaded means that will, the way they are asking question may lead you to answer in one way or other. But that is not the type of question they are asking you here. What is wrong with this type of sampling method? It is too expensive, or we don't know about it. Response may not reflect the opinion of the general population. Yes, that's right, because it's a voluntary response. It is too time consuming. Okay, we don't know about it. Many people may choose not to respond to the survey. Yes, that might be true. Okay, so that was the first one. I am going to, let's choose the next question. Let's say this one. A magazine ran a survey about a website for downloading music. Readers could register their response. A reader could register their response on magazine website. One more time, this is a voluntary response sampling process. Choose the correct answer below. The sample is voluntary response sample, so there is a good chance that the results do not reflect the population. That's right. Choose the correct answer below. Even I don't have to go through all the responses after that. Okay, let me just choose randomly another question here. In a survey conducted by a wedding planning website, 1228 married or engaged women were asked about the importance of a bended knee when making a marriage proposal. Among the 1228 responded, 36% said that the bended knee was essential. So this is the information we have given. Remember, the sample size is 1228, but the sample is coming from married or engaged women. So the first question is, what is the exact value that is 36% of 128 survey responded. So if you multiply 128 by 36%, which means 0.36, so just multiply. I'm going to use my calculator here. Just multiply 1228 times 0.36. 0.36 means it's a 36%. So one more time, 1228 times 0.36, which is 442.08. Type an integer or decimal, do not round. So the answer is 442.08. So this is the decimal form, do not round. That's the first question. The second one is, could the result from part A be the actual number of survey respondents who said that a bended knee is essential? Why or why not? Okay, so let's look at the responses. Yes, the result from part A could be the actual number of survey respondents who said this because the polling numbers are accurate. No, the result from part A could not be actual number of survey respondents who said this because a count of people must result in a whole number. Part C, no, the result from part A could not be actual number of survey respondents who shared this because that is a very rare outcome. Finally, yes, the result from part A could be the actual number of survey respondents who shared this because the result is statistically significant. Okay, here is the thing. The answer is part A. Yes, the result from part A could be the actual number of survey respondents who said this because the polling number are accurate. Okay, let's see. Okay, why is this? Why it's not right? No. Okay, yes, it's a B, because the answer should be a whole number. But here you can see that it's a 442.08, so it's not actually whole number. The number of people could not be a 0.08, so it's not from the actual survey, it's just made up survey. What is the actual number of survey respondents saying that the bended knee is essential? The actual number of survey respondents with this response is 442. Yes, so because that sounds that's the nearest whole number, that's why it's a 442. Among the 1228 responded, 88 said that bended knee is corny and outdated. What percentage of respondents said that a bended knee is corny and outdated? So 88 out of 1228, so just divide 88 by 1228. If I do that, 88 divided by 1228, it gives me 0.0071666124, round to the nearest whole number. So to go to the percentage, I have to multiply this decimal by 100, which gives me 7.166. Round to the nearest whole number as needed, so it would be 7%. That's the nearest whole number. Okay, so that's how we can answer this question.